A couple of different ways you can handle this problem. If you did a previous problem and it was in standard form, you could expand that function into standard form. Because something squared means it's something times itself. So you could write it like this. And there we go, it's a subtraction sign there. And then you can multiply this out until you get x squared plus something x plus something. Put it all in ax squared plus bx plus c. Put it in standard form. But there's another way to do it too. This function is in something called vertex form. When it's factored like this and there's just a piece on the outside. Look, if you put a 4 into this function, 4 minus 4 is going to give you 0. 0 squared is 0. Minus 2 is going to give you negative 2. That's actually the vertex of the function. When you graph it, if you plug in a 4, you get out a negative 2. That's going to be the vertex where it peaks. And so if we want to put that in a sketch of a graph real quick, so far we have 1, 2, 3, 4, negative 2. There's a dot right there. That's going to be the vertex. So that means the axis of symmetry is always right on top of the vertex. That's where the symmetry, it's not really straight, but the symmetry is going to happen on that line at x equals 4. So that makes our axis of symmetry x equals 4. So the y-intercept is always the piece that's hanging out by itself when you expand the whole thing. So if you were to expand this whole thing, the y-intercept would be whatever's left over. It would be what c is when it's in standard form. But if you're trying to avoid expanding it, you could do this. Y-intercepts occur where x equals 0. Wherever it crosses the y-axis, wherever it crosses here, these are all x-coordinates of 0. So by plugging in 0 into this function, you can find out the y-intercept. And if you put a 0 in there, 0 minus 4 gives you negative 4. Negative 4 being squared gives you positive 16, and 16 minus 2 gives you 14. So our y-intercept is 14. X-intercepts are a little bit trickier, though. X-intercepts are where you set y equal to 0. So we set this whole function equal to 0. And then we've got something to solve. So if you come to this point in the course, you should probably have solved a quadratic equation like this before. This one, since everything's being squared in that parentheses, let's get the parentheses by itself. And then we can use a square root to get rid of that squared. Let's try a different color. Take a square root to cancel out a squared. And that's one thing you got to remember is every time you use a square root to cancel out a squared, there could be a positive or there could be a negative answer. So I'm going to do positive or negative square roots of 2 on that side. Where's my black ink? That's equal to x minus 4. So you have to solve twice. You add the 4 to both sides. You get 4 is plus or minus the square root of 2 for x. Those are the x-intercepts where it crosses the x-axis. So now that we have these pieces, let's graph the y-intercept. That's going to be way up here. In fact, it's probably too far up to graph. Y equals 16 is somewhere way up here on the graph. But because of symmetry, because that's the axis of symmetry, we know there's going to be one like that. So a rough sketch of the graph looks like this. One thing you'd want to make sure is when you make the graph, you found out your x-intercepts were these decimal numbers. You can convert these to decimals. So something a little bit less than 4, a little bit less than 3, probably a little bit greater than 3 are where they should cross the x-axis. Whatever those decimals are, that's where your graph should be crossing. And with my rough sketch, it is a little bit less than 3, so that's good. And that looks to be about symmetrical. So this is a rough sketch of the graph.